So what's important about the KT boundary in Zumaia? First, we have impact evidence. We see a very thin millimetric layer with an anomalous concentration of iridium. The iridium is a very rare element on Earth, but it's very common in the outer space. So after the impact of this asteroid in the Chicxulub crater in the Yucatan Peninsula, there was a series of sedimentological processes in the Gulf of Mexico, but the evidence of the impact in very distal areas, we are very far from Mexico, we are in Spain, we only see this very thin layer of iridium, as well as other impact evidence. So that's one of the important points of the KT boundary here in Zumaia. We can see the impact evidence. Second, we see the extinctions. We see the extinction of 90% of the species of calcareous plankton. So why did it go extinct? Because of the impact, or because of the massive wildfires, or there are many hypotheses? Well, here in Zumaia, we can see that 90% of the species of calcareous plankton disappear right at the boundary. But that's not the case with the benthic foraminifera that lived at the bottom of the oceans. So one can speculate that after the impact, there was a huge amount of gases, acid gases, thrown out into the atmosphere, and they fell down as acid rain. So if we can think of a very short, very rapid event of acidification of the surface of the ocean, we dissolved the shells of calcareous plankton, the unicellular organisms that were floating in the water column, and these went extinct. In contrast, benthic foraminifera were living at the bottom of the ocean at 1,000 meters depth, and these were not affected by the acid waters.